Hello viewers, I am Kausalya. Today we are going to solve problem number 1 under the category steady state error. For a unity feedback system, the open loop transfer function is given by this. Find position, velocity and acceleration error constants. And the second one is find the steady state error for the given input. This is your input R of S. It is given by this expression, right? So our first thing asked is position, velocity and acceleration error constant, right? So before that, you look at the problem. The type of system is a open loop system, right? So the open loop transfer function is given here. And the type of feedback is unity feedback, right? So for unity feedback, what is the value of H of S? The value of H of S is 1. So the first step, we are going to calculate static error constants, and as I said, for unity feedback system the value of H of S is equal to 1. So what is the formula for positional error constant? It is given by limit s tends to 0 g of s into h of s. G of s is given in the problem and the h of s is equal to 1 for a unity feedback system. So just substitute the values here. When you substitute the values, you see limit s tends to 0, this is your g of s and the value of h of s is 1. So again when you apply the value of limit s tends to 0, that is we are going to substitute 0 in the place of s here. So 10 into 0 plus 2 divided by 0 into 0 plus 1. Right. So anything divided by 0 is nothing but infinity. So here the answer is infinity. The value of positional error constant for the given problem is infinity. Right. Then we are going to see velocity error constant. So again the velocity error constant, the formula is limit s tends to 0, s into g of s into h of s. So the limit s tends to 0, s into the, just substitute the value of g of s here. When you substitute the value of g of s here, this s and 1 s get cancelled here. So the remaining term is 10 into s plus 2 divided by s into s plus 1. Right. So the next thing, just we have to substitute the value of s equal to 0. So when you substitute the value of s equal to 0, what happens? Again, anything divided by here, the denominator term becomes 0. So anything divided by 0, it is nothing but this is our infinity. So again, velocity error constant is infinity for this problem. Next, acceleration error constant, and it is given by this formula limit s tends to 0, s square into g of s into h of s. So again substitute the value of g of s here, the value of h of s is 1. So when you substitute the value, you see this s square and s square cancels each other, and for the remaining terms you have to substitute the value of s as 0. So when you substitute here, what comes? 10 into 0 plus 2 divided by 0 plus 1. So again 10 into 2 becomes 20, 20 divided by 1 is again 20 here. So this is the value of acceleration error constant. Next, we are going to find the steady state error. This is our second part of the problem. So as we all know, the formula for steady state error is limit t tends to infinity e of t, right? So what is the formula for e of t? E of t is given by r of t into c naught plus r dot of t into c1 plus r double dot of t into c2 by 2 factorial plus it goes on. Right. Here the value of r of s is given as 3 by s minus 2 by s square plus 1 by 3 s cube. Right. So when you look at the formula, we are in need of r of t, right? But what we have is r of s. So from this r of s, we need to find r of t. So just take inverse Laplace transformation. So when you apply inverse Laplace transformation, what happens? So these are all the basic formulas of inverse Laplace transformation. So inverse Laplace of 1 by s is 1 and 1 by s square is t and 1 by s cube is t square by 2 factorial, which is nothing but 2 again, right? So just substitute the values accordingly here. So when you take inverse Laplace of 3 by s, 3 remains as such. And what is the value of 1 by s? 1 by s is 1. So 3 into 1 becomes 3, right? Again minus 2 by s square. This 2 is a constant. So write this minus 2 as such here. Then what is the value of 1 by s square? So when you take inverse Laplace of 1 by s square, which is nothing but t. So just substitute the value of t. And again for 1 by s cube, it is t square by 2. So keep this 1 by 3 as such here. And for s cube, it is t square by 2. Right. So when you simplify this, the final equation is 3 minus 2t plus t square by 6. Right. So finally we had find out the value of r of t from the given r of s. Our next step is to find r dot of t because r dot of t is required in the formula. So r dot of t is nothing but d by dt of r of t. You have to differentiate r of t with respect to t. So what is your r of t value? We had obtained r of t from the previous case here. So just substitute this r of t here. Again we are going to differentiate with respect to t. So when you differentiate a constant, its value becomes 0. When you differentiate minus 2t, it becomes minus 2. Plus when you differentiate t square by 6, that becomes 2t by 6. I hope you people know the differentiation problem. So the differentiation problem, this is the basic differentiation formula, that is a to the power n. When you differentiate this one, that is this is differentiated with respect to n here. So when you differentiate, what is the formula? N into a to the power n minus 1. Here we are having t square. So t square, when you differentiate this, here the value of n is 2. So 2 into t to the power 2 minus 1, so which is equal to 2t, right? So when you differentiate t square, you are getting 2t, and here in the denominator I am having 6, so I am writing this as such, right? So finally r dot of t value is minus 2 plus t by 3, right? Hope you people are clear with this. The next step, we are finding r double dot of t. R double dot of t is nothing but d by dt of r dot of t. So d by dt of, what is the value of r dot of t? It is given by minus 2 plus t by 3. So again we need to differentiate this expression. So here minus 2 is a constant. So when you differentiate, its value reduces to 0. Whereas when you differentiate t, so this is your t to the power 1, right? So the formula is n into t to the power n minus 1. Here the n is 1. So here I am writing this as 1 minus 1. So which is nothing but 1 into t to the power 0. So anything to the power 0 is nothing but 1. So 1 into 1 is equal to finally 1 here. So while differentiating d by dt of t by 3, the value of t becomes 1 here, and here I am having denominator as 3. So the final answer is 1 by 3, right? The next thing is we are going to find r triple dot of t. So just differentiation of r double dot of t gives r triple dot of t. So r double dot of t is nothing but it is 1 by 3, we have just seen. So when you differentiate a constant, the differentiation of constant is equal to 0, right? The rest of the problem will be continued in the next video. Hope you people understand. Thank you.